Okay.
So with disrespect, I'm gonna give you a piece like Halo there.
Alright. Today, we are going to take a look at solving right triangles. What that means is we are going to find all missing sides and all missing angles. Okay? So, over the last couple of weeks, we've looked at different methods to do that. Okay? To find a missing side or a missing angle.
Is this pretty much just they give you a triangle and they give you limited information and then you just use everything you know to try to find the sides?
Exactly. Yeah.
So can I actually my headphones?
You know what you do. Alright, so we've talked about two different ways to find missing sides in a right triangle. What's one of them? How can I find a missing side in a right triangle? We've talked about two ways to do that. What's one of them?
Pythagorean theorem.
We can do Pythagorean theorem.
Tan, cos, sin, SOHCAHTOA, do all that stuff. I don't think
So, Pythagorean theorem is the a squared plus b squared equals c squared. Right? So we can use that to find a missing side. Or, like he just told us, we could also use the trig. Right? We use sine, cosine, and tangent to find missing sides in right triangles as well. Now, we've only talked about one way, then, to find missing angles. What did we use to find missing angles? This is what we just finished doing. How did we find missing angles?
it's
in right
like
triangles?
doing like tan.
Yeah, so we were trying to solve for theta, and to do that, we used our inverse trig functions. So our inverse trig functions were inverse sine, inverse cosine, and inverse tangent. Okay, now there's one more idea, okay, that's going to make solving for angles in these triangles a little easier at some points. Okay, we'll have to use inverse trig functions sometimes, but another idea that we can use is the idea that all angles in a triangle add up to what? 180. Right? So that property is going to be very useful in this section. So all angles in a triangle add to 180 degrees. Okay? We're going to use all four of these ideas to solve for different missing pieces in a right triangle. Okay, so all we're doing is taking all this stuff that we've been talking about and combining it into one problem, basically. Okay? So let's take a look at this first example. And I'm going to scroll down a little bit so we've got some room to do some work. So, to organize our work, okay, this is important. To organize our work or our answers, I guess, we want to list out all three angles and all three sides. Okay? The way that's going to be presented in most of the things we do, we're going to have angles A, B, and C, where C is the right angle. Okay? We've already talked about drawing generic triangles like this. C is the right angle, capital A, capital B are the other two angles. Now, how did we label the three sides then? If capital A was here, angle capital A is here, where is side little a? Opposite of it, right? So this would be side little a. Where would side little b have to be?
Where the 12.1.
Right, where the 12.1 is, so that would be my little b. And then that leaves little c is here. Okay? So I know a few of these pieces of information already, and I have to be given some of them. Okay? Well, I don't know angle A. I know angle B is 39, and I'm given that. I'm given that angle C is 90. And then I'm given that side B is 12.1. Now I need to solve for the other three missing pieces. I need to find the measure of angle A, the length of side A, and the length of side C. It's probably going to be easiest to solve for A in this case. How can I solve for A right off the bat? Angle A, I should say. If I know two angles already.
Just track 180 by 90.
Exactly. Right? Take 180 minus 90 minus 39, and that's just going to give us the measure of angle A right off the bat. I don't have to use any trick. All I'm doing is saying I know all three of these have to add up to 180. If I know two of them, I can easily find the third. So what does that get us? 51. Okay, so right off the bat, I got that the measure of angle A is 51. Okay, and what we did, we took 180 minus the measure of angle B minus the measure of angle C, which was 180 minus 39 minus 90. That got us 51 degrees. Okay, so we got one done. Now I need to solve for either A or C. Which one do we want to solve for first? It doesn't matter.
A.
A? Alright, let's do A. How am I going to solve for A? What am I going to have to use if I only know one side in my triangle? If I only know one side, I can't use Pythagorean theorem. Right? We have to know two sides to use Pythagorean theorem. So I'm going to have to use trigonometry if I only know one side. Okay, so if I'm solving for A, and I know B, those are the two sides I'm going to work with. Right? So with respect to this angle that I'm given, is B opposite, adjacent, or hypotenuse? Opposite. Is A opposite, adjacent, or hypotenuse? Adjacent. So to solve for A, what trig function am I going to use? Tangent. So what's my setup going to look like? Tangent of 39 equals 12.1 over A. How do I solve that? Yeah, multiply both sides by A. Right, yeah, so then I'll divide both sides by tangent of 39. And we end up with A equals 12.1 over the tangent of 39 degrees. What does that get us? 14.94. Okay, so almost done. And we just have one more thing to solve for. So I'll go ahead and write that on my triangle here as well. It's 14.94. So now, how can I solve for C? We actually have a couple of options here. What do you guys think? So yeah, we could use another trig function. That would absolutely work. Or we could, if I know two sides in my right triangle now, we can use Pythagorean theorem. Right? So it's entirely your choice. Okay? Once you know two sides, you can either use another trig function or you can use Pythagorean theorem. I think a trig function would actually be a little bit less work. So, but just to show a different method, I'm going to do Pythagorean theorem here. Right? So if my Pythagorean theorem is a squared plus b squared equals c squared, I'm going to have my a is 14.94, 14.94 squared plus 12.1 squared equals c squared. So I'm going to need a little bit of help here. I don't know what those squared are.
How would you know that?
Not that good.
Let me help. The first one is 200
Now, just want to add those together. Okay. So, what does that give me? 369.61. Now what? Square root of the square root. So what's the square root of 369.61? Say it again. 19.23. Well, we should get the same answer either way. Is that what we got? We square rooted that? Perfect. Alright. So this is how we're going to solve right triangles. Now, on both of the examples, I listed all 6 of these pieces of information for you. Okay, when we get to a practice and a graded assignment, you are going to have to organize your work yourself like that, or organize your answers yourself like that. Okay, so it's a good idea to just write measure of angle B, measure of angle A, measure of angle B, measure of angle C, A, B, C. So list out your 6 answers there. Okay. Questions? All right, then let's flip over and take a look at example 2. All right, so in example 1, we were given one side and one angle. In example 2, I'm given 2 sides. All right. So let's first go ahead and list out what we know.
This is the back.
Sure. C is 90.
Little a is 11.8.
Little a, opposite big A is 11.8.
Little b is 14.
Little b is 14. Right, yeah, so that's what we know. So we have to find measure of angle A, the measure of angle B, and side C. Like,
Okay, got the whole thing.
all right, which one did you solve for first?
I think I tried to solve for angle B by
Okay.
doing putting the theta in there and then making 14 my opposite, my 11.8 my adjacent, and then C hypotenuse,
Right, yeah.
and then C will with opposite adjacent, and that's tan,
That's-
tan, and I put the theta in the parentheses, and then 14 over 11.8, and I do both sides by 10 to the negative 1, and then that gets theta equals 50 for B, and then 50 plus 90 is 140.
Hold on. Going too fast. All right, so Mike, you first solve for angle B. Right, label the sides opposite and adjacent. That would be tangent. So we get tangent of theta equals 14 over 11.8. We take the inverse tangent of both sides then. Inverse tangent of 14 over 11.8, we can put in the calculator.
Why is there a -1?
So, it's kind of skip a step here. So, to get theta by itself, we have to undo tangent. To do that, what we do is take the inverse tangent of both sides of the equation. When we do that, inverse tangent of tangent cancels out, and I'm just left with theta over here. Then on this side, I get inverse tangent of 14 over 11.8. That's what we can put into the calculator to get that angle. So what did we get for that? 50 exactly. Sweet.
You do 50 plus 90 for C.
Alright, so we just found that angle B is 50 degrees. So now once I know 2 angles,
And subtract 180, and then equals A.
exactly. Right? So now I don't have to use inverse trig to find the other one. I can just use the idea that all 3 angles add 180. So 180 minus 50 minus 90 gets me 40.
Now, do Pythagorean theorem. You get 14 squared plus 1.8 squared equals C squared. And you do that whole number. And now you get
So yeah, now since I know 2 sides, I can just use the Pythagorean theorem to find the third side here. So I can say a squared plus b squared equals c squared. My a is 11.8, so 11.8 squared plus 14 squared equals c squared. So what's 11.8 squared?
Oh yeah, I might round it up.
You told me it was exactly 50.
I can remember.
Let's see.
I got 49.87.
Yeah.
It all rounds up to 50.
That would round up to 50.
It's 49.87. That's about 50. That food.
49.87 should be what we get there.
What a bunch of narcs. Depends on that.
Alright. So we get 49.87 for B.
Okay, A is 40.126.
So
Did it make you happy?
there we go. I want you to round to the nearest hundred.
Oh, I rounded.
Yeah, you rounded to the nearest whole number. I want you to be as exact as possible here. So round to the nearest hundred. I guess exact as possible would be rounding, would not be rounding. I want you to round here to the nearest hundred. Alright, so what's 11.8 squared? 139.24. And 14 squared is 196. I know that one off the top.
Okay, I believe this one is 335.24. Is that correct? Oh, now you're not checking.
So what's the square root then of 335.24?
18.30956034.
So if we round to the nearest hundredth, 18.31.
Yeah. I'm not saying.
So that is our last piece of needed information here.
That's not that bad. I thought it was going to be harder.
Yeah, that's because we already know how to do all of these individual things,
Yeah.
right? We're just kind of putting them all together now.
Now, are you going to give us big fat practice sheet to study for the test?
So now we've got practice.
A big fat practice